Hi guys, I said I'd do a follow-up of both the videos I did recently on these two types of sensors. So far I'm going to use the one that's easiest, that I taught myself to hook up, and then I'll teach the other one on how to hook it up after I do this video here. But this here is your PIR sensor, PIR motion sensor. It means passive infrared motion sensor. And what this means is if you're moving in front of it, like moving and stuff like that, it'll turn on. It'll activate and then turn off after a second. I got mine that's default with these little knobs. I'll explain them in a minute. But I got mine as a default of a second only that it stays on. But what happens is when you wave your hand over it, it turns on. But if you stay in front of it, it'll turn off and not do anything. It will no longer see you until you move away or come back to it again. This is what this one does. The other one does. The other one works differently, and what the other one does, it's an ultrasonic sensor, which I'll be showing in the next video down the road. And what it does, it can tell a distance away from an object that's alive or still, that's not animated at all. But we'll get to that one when I do the next video. But for now, this is our passive infrared motion sensor here. And we're going to learn how we hook this up to a Raspberry Pi, and I'll even display the Python program to go with it. And you guys can type it down, or you can go to github.com and find it there on my username RoboMasterS1. And here we go. Now we're going to go like this, and I want to show you all the way here. This wire here is going to be the ground. And then this wire here, the purple one, that's going to be the output, where you want your light to light up, whatever. That's going to be what you want to activate, like your light or anything you want. And this other one here is your ground. This white wire on right is your voltage. This white wire right here, I couldn't find red. And this jumper wire, I wish I could have, but I wanted it to be red wire, not white. So this is your voltage, looking at it this way. Okay. So voltage, output, and ground. Voltage is always to the left. The ground's always to the right. Remember that. And the output's always in the center. They usually call it just out for short. Okay, and now we'll go to your light. Now, the thing about these sensors, they hook up with wires that look like this. Okay, see how that end's got no end on it, like a point, no contact, just that little. You can see a little hole in there. There you go. I'm trying to focus it better. See that little hole? Well, this end looks like the same kind of end. It only has a stick on the end of it that you could actually make a contact, the male end of it. The other end, one end's the female, and this end's the male. If you want to call it that, which do you call it that in electrical terminology? Male and female. See? This is female. This is male. Okay, so what's going to happen is they plug into here, even though I've already done it. Okay, I've already done it, but they plug into here. That's how they go. And you gotta make sure you have ends that are like that. Oops. You gotta make sure you have ends that are like that. Okay? Just like the same in here that's attached to one big wire itself. Just make sure you have an end like that. I also have wires that have only 2 female ends. I only got a few of those, so don't be confused. Get the one that's a female and a male to use that with this kind of sensor. Now what we're going to do is we're going to use this little tiny breadboard. And you see that breadboard cobbler wire right there, the blue cobbler wire? And it's great for breadboards if I could have enough of making it. And if I got good cutters that do cut it good, but I can't get the right size to that breadboard length holds on a lot. I'm having trouble doing that. So these are already set that I got with a little kit that I bought separately. The little tiny breadboard core wire kit. Real tiny thing, actually didn't get much in it really. But other than that, this is what we're going to use. And now here is the goodies. This is the goodies right there. That's the goodies we're going to use. We're going to use these goodies right here. So we're going to use all these little goodies right here. Okay? And except for the orange wire, we're going to be using these wires. Get rid of that one now. I just wanted to show you what we were using. But this is what we're going to be using right here. So let's see how many wires we got. We got 1, 2, 3, 4, 5, 6, 7. Okay? 7 wires. Plus, you might want 2 for the Raspberry Pi 4 fan. Okay, like I got. It's good to have a fan for this, that way you can do heavier projects. And what we're doing, I don't even need a fan on, but I'm glad I got it there anyway. It allows me to use this thing for hours, so I recommend the fan on here. I really, really do. I'm glad I did what I did there. But anyway, we're going to get back to this. Now, here's where I'm going to need my little special glasses here to see. These things are great to see with. You just won't see me working with them, that's all. But this here, we're going to start doing the breadboarding, alright? I just want to make sure I get it all right for you so I can actually show you. Now see this little blue copper wire here? That's a divisor bridge. I want this bridge to be connected to this side. Only this one column. Okay, so far. Now we're going to take this puppy. See the long node? We're going to take this long node, and it's going to go. Hope I can film this right because my laptop's it away. And if I don't, I'm going to show you what I did, alright? I'm going to put it down here more so I can really touch it up. Now, what I did, see how I got the long, I put the long lead where the blue strip is. Okay? Because for some reason, it's going to want to be the positive when I put it into the 5 volts. When I do it the other way, it doesn't want to work. So I don't know if it's my flipper that's electrically backward or the breadboard here that I'm using. But in any case, it's going to work. But see that, how I got it lined up like that? Okay, now we're going to take our little friend, the resistor. This 220 ohm resistor. It's got 2 little red bars on it. It's a little hard to focus on here. I'll try to see what I can do. It's usually they're gold. The blue ones are usually the cheapy ones. The wires been too easy and stuff. So I bought myself a pack of resistors, not through a kit. But this is what I got here to use. A 220 ohm resistor 1 is all we need, okay? Now I'll plug this in. Okay, I'm gonna have to do it this way just to make it easier for me. Okay. See how I got it plugged into here? Now what I did was I got the resistor plugged right into that same lead. The positive leads into the cathode to the LED. See how it lines up? I got the resistor jumping over like a bridge. Okay, because it's also acting like a bridge. It's acting like the blue wire, okay, but it's a resistor. It's not a blue wire, it's a resistor that's going to allow only a little bit of power to go in to light up our lead. That's all it's going to do. I can't take full 5 volts or it'll blow the lead, so I need a resistor, like a pressure tap, slowing down the water. That's what I need. So that's what we got right there, a 220 ohm resistor, alright? And it's in the same slotted holes as you see, where it goes to the contact underneath. We got that like that. Now we got to hook up our buzzer to get that ready. This is our buzzer, okay? I should have showed you maybe. It's got a short pin and a long pin, if you can see that. The short pin, I presume is the positive. Oops. The positive, let's just see. Oh, I guess the long one's the positive. There's a plus sign on that side. Okay, I guess the long one in this case is the positive. It's not a cathode. It's not an LED. I assume the long one is the positive. But what we're going to do is we're going to plug this into the 2 extra little tiny breadboard lines there. See that? That's going to be plugged into there. that empty space right there where those 2 extra are. That's where this is going to go. Now we're going to put it into here. That goes like that. See how I got it lined up? Okay. And the positives on that side. And yeah, the positives on that side. The ground is on that side. But we're going to see which way it works once we hook it up. Like I said, this little guy is weird. This little breadboard, it's kind of weird. But it works great. But now it's time to have it fun to hook it up. But first, we got to go back to this guy and hook him to the Raspberry Pi. So while I do that, I'm going to get this Raspberry Pi cooking. Okay, we're going to do some cooking with the Raspberry Pi. And if you want to see the magic screen, we'll look at the magic screen. There we go. Let's see our little Raspberry Pi come on. Sometimes it takes a minute because the more you have in your Pi, the longer it takes to boot up. As long as I see a screen like that, or those 4 Raspberry Pis, that's a good sign. If I don't see any Raspberry Pis, that's a bad sign. Now we're going to go like that. So I can place it a bit at the Raspberry Pi's bar there, the breadboard. Okay. You got that like that, right? Okay, well, what we're going to do is, I'm going to have to take this guy here. I'm trying to display it somehow. We're going to take this wire right here. We're going to put him way up in the second 5 volt. We're going to take this wire. Okay. This wire here is going to go to this pin 11 that I got as a piece of breadboard cobbler wiring. That's where that's going to go. Okay, now we got that like that. See, I got that in pin 11, okay, from up here. All right, but it says up, this sure shows the Broadcom numbers, not the breadboard numbers I'm using. So I'm really using 17, okay? I'm using 17 for this guy right here, okay? 17, pin 17 really. That's pin 11. What I use is breadboard, that'd be pin 11. That's how I call it. And the next one is pin 13 over, and then I'm using pin 15, which is direct pins, breadboard. Just let you know that. Now, this here is going to be my ground. I gotta kind of go like this. I hate doing it like this because the cords ain't long enough. I don't get a long enough cord. Now we're going to take this guy and we're going to start hooking these pieces up. Now we put these into the ports. We don't put them into the sensor. The sensor's all hooked up. We got our positive wire. We got our positive wire over here. This white wire that you see, it's in the 5 volts, my second 5 volts. I don't know why they don't give you 3 volts, but they don't. I got 1 3 volt on this side and 2 5 volts on this side. So this is what I'm using here for on the left side is the 5 volt of the thing. It doesn't need a resistor at all. You're good to go with this kind of sensor. And then I got the out in my number 11 pin on the breadboard. And then I got my ground to make the thing ready to get active. Now we're going to start hooking up the things to this. Okay? Now here's what we're going to do. We're going to test the pieces as I hook them up. First I'm going to attach my little black wire. Red wire I need on that side. My black wire can go there. My red wire can go here. Now, here's what we do. I'm going to be putting these into pin 13 and 15. That's what I'm going to be doing right here. These guys here, I'm going to be putting them in the pin 15, 13 and 15. Alright? That's where these guys are going to go. Oh no, sorry. Thinking of something else. Never mind. This is my ground. This is my ground. This is going to be pin 13. Sorry about that. Thinking of something different. I'll show you when this is all hooked up and point the camera at it. It's just a little tricky because everything's small here. I don't get enough long cord for it, and I got no extra attachments. I looked and looked and looked. I got what I get. Okay, we got that in pin 13, and I got this guy going to go to ground. Okay, now we're going to test it. I'm going to open the program so we can test it. And we'll go back to looking at this so you can see what I'm doing. Alright. Alright, we're going to check this out and see if I got it hooked up right, alright? Now we're going to go like this. So I got it hooked up right. Let's find out. Yep, see that? I'll show you. I'll back this up, and we'll look some more. Oh, I can't back it up any further. We gotta back the camera up. Okay, watch me wave my hand over it. Okay. I'll just get rid of this light for a minute. Watch me when I wave my hand over. See that? Now watch the light turn off. See that? Now we're going to hook up the buzzer. Let me take these glasses off, bring my lamp back over. Now we're going to hook up the buzzer. And it's always good to do this. I got to go to my keyboard and push the keyboard instructions. The screen again really quick. I had to walk over to my keyboard because I got no room to put it anywhere here. I'm going to show you the screen really quick. In the programming, anything I show, it's always important to make a keyboard interrupt. Okay, in your program. That way when you push Control-C, it makes all the pins turn to off. That way, should you plug something into the wrong pin in your breadboard or Raspberry Pi directly, you won't fry something. Turn your pins off. That way it avoids you getting mildly electrocuted and breaking your electronics. Chances are the Raspberry Pi can't hurt you, but you can hurt it if you're not careful. So do be careful. Always stop your equipment the right way. If you just push stop, the little red button that you see on the very, very corner, I'll show you right here in the menu. If you just push the stop button by itself, this won't matter. The pins will still be alive. It's always recommended that you do a Control-C, or that the program stops with a GPIO.cleanup. If you want to even stop it that way with a program that runs itself, that's even good too. But you got to make sure you stop the pins. You have to make sure, because the stop button doesn't know that you stop the pins, and you can't set it to where it knows that you stop the pins. Only Control-C can do that. So always be aware of that, okay? Now we're going to look at the sound. This is going to be a lot of fun. Your neighbors are going to love this. Your neighbors are really going to love this. Yeah, they're going to love this. They're going to love me when I do this. Now I just want to make sure I got this in the thing. I think that goes like that. Because if I'm right, that's on the negative there. We're going to plug this into the negative on this breadboard rail. And I forgot to mention a little tiny piece of breadboard cobbler wire right here on my negative to my ground. I got that there so it can feed along, like I told you before in some other videos. Okay, we got this like this. And now I'm going to take Mr. Red wire, And he's going to go into the positive part of the sound. We'll try it again. And if it doesn't work, I just switch my wires around. I just might have had something backwards if it doesn't work. You know, mistakes can happen. It's good to make mild mistakes, but it ain't good to make bad mistakes. Now this will go into pin 15. As soon as I can get it in, push this out of the way to get it in there. A little crammed in here. It's so crammed I can't even get to the right hole. There we go. Now I'm gonna look at it. I'm gonna show you to look at it. See how it looks with all the wires? See that? Now, see how they're not really connected to the actual sensor? It's going to be programmed to tell the sensor what to do with the output pin. This output pin here is controlling all this. Every time this senses, these wires here and here and here are going to release power to go to that. This won't know that this is doing that. This here is only in charge of sensing something to let it go here. I got nothing contacting to this wire. They're all their own separate columns, as you can see, okay? It's just the programming itself makes the sensor activate to do what you want to do. Now let's see if our little buzzer works. Let's see if the neighbors are going to love me. Or my friend that's still sleeping. Okay, let's try this. Hear that? That is what a sensor is. A PIR sensor. A passive infrared sensor. Now I'm going to show you something like I tried to explain. Since we got this all hooked up and everything all hunky-dory good to go. And by the way, in this one particular program, it doesn't matter how you... Okay, we're going to go kill this. I'm just going to kill it right here because I'm not going to actually do anything to pull the pins out. So I'm going to push the stop button so we don't get interrupted. Okay, so what happens is, if I put my hand in front of this and I stay there, this will only work once. It won't keep doing it. And I'll show you what I mean. Okay? And I'll show you the output. Oh, I didn't have to do anything that time. I'll do it again. Come on. Now if I stay there, nothing else will happen. See how nothing happens? If I go to move away, see that? Then it gets me. The other sensor I'm going to show, the ultrasonic sensor, the HC ultrasonic sensor. The HC ultrasonic sensor is the sensor that it can judge distance. You can make a program, which I actually will view in the thing and let you see it on the monitor. When I do that video, it can judge distance of objects alive or not alive. And if you stay there, it'll still bounce the echo waves off it. That is an ultimate sensor. That'd be great for robotics. And that's what I'm also going to show next. But now how to use that one for, I still don't know. But at least I'm going to show us all how to hook it up. I even had to go learn how to hook it up. I had to go to techboy.com for that one. TopTechBoy.com. He helped a lot, trust me. Yeah, guy's a good guy. If you're into electronics, go to him. He explains it easy. He'll start off small, gradual stuff, and then he gets bigger as he learns his lessons on the Raspberry Pi. I don't use him totally to learn from. I go all everywhere, but he's my easiest guy to learn if I learn something new. I usually pick TopTechBoy.com is the guy I usually pick. His name is Paul McWhorter. That's what his name is. He's on YouTube. Look for him if you're into this kind of stuff. He won't disappoint you. He really, really won't disappoint you. But anyway, back to this. Now, as you can see, everything's all hooked up, and you just made yourself a sensor, a PIR sensor. That, like I said, you can adjust these knobs, but I just left them at their default. Oops, didn't do the camera again. I just didn't adjust these knobs at their default here, that's all. But you can adjust those. But if you got this thing going while you adjust them, just be careful that you don't slip with your screwdriver, just in case you short something out in there. You won't hurt yourself, but you could hurt your sensor. So be very, very careful of not touching metal on wires while they're alive. Please be careful, even on big electrical stuff especially. You don't want to play with 120 volts and hurt yourself. Playing with a 5-volt battery is different, but like I say, it's still plugged into a wall. It's not really 5 volts. It's going through an adapter, a capacitor, if you want to call it that. It's going through a big adapter that's cutting down the power down to 5 volts, so it's between 3 and 5 volts. But a Raspberry Pi has 2 5-volt inputs and 1 3-volt output. I don't know why they did it that way, but they did. So I just used a little tiny piece of red wire to go to the power bar on the thing, right over here, if you can see it. Right there. See that? Right there. I got that connected to go like that, so I can slide right along. And then this one here, I got this connected to the ground to slide right along. That's how I do things. I use the rail. I slide along the rail all the time. I surf the rail as much as I can. But like stuff like this, sometimes you can't surf the rail. You gotta plug the inputs into the inputs and things like that. So there's times you just can't do that. But most of the time, to get your power going from an energy hub only source, this is what you got. Alright, but this is here is how it goes. I already had taped this to the glass, but you got the schematics, okay? Now I'm gonna unplug the sound because it's kind of annoying. I don't want to wake my buddy up, but we're gonna show you what the numbers do on the screen. Alright? What the output looks like that you printed out. I don't want to plug that into a wrong thing because the wires will still come alive. So what I did, if you're using a breadboard like me, you know you want to make something work again, but you don't want to use some kind of power, but you want to keep your cord attached in case you want to do something. What I did was I took this. What did I just do here? Where did I just put that? I just unplugged something. Where did I unplug that? Yeah, here it is. What I do is, boy, the wires are so messed up. What I do is, I took this out. Okay? I'm sorry, wrong end. To be safe, I took this out of my thing just because I'm not using the sound, and I just put it into a blank part of my breadboard. That's not touching any poles or rails. Just nothing else touching, okay? And I can even put it here because there's nothing touching my input, so I can put it anywhere as long as I got no other wires touching here to cause that to fire. But I don't want to put it here or here. I got it right out of here, so that way it's out of the way. Now we can try our thing and look at the screen without annoying anybody. Let's just see how we look here. Now see how it's like this? Now see how it goes back to 0? Now I'll wave my hand. See that? Now watch. Do it again. See that? Now it'll go back. It stays on for about a second. We'll pull away so I can show you again like this. I didn't have to touch it. I just have to move. I didn't have to touch anything. And then when I force it, it doesn't want to do it. Come on. All you gotta do is just move. And it sets it off. And then now I want to do it purposely. It's trying to give me a hard time. And it's like right over like this. The light could be doing it too, though. Come on. Go on. I might have to adjust that to be stronger. Because I didn't, like I said, I only left it at the default. I didn't turn it. I left it as it was because I don't know what to use it for yet. I didn't make anything out of it, but when I do, then I'll be picky and use it. But I'm gonna definitely put that on something when I get back and when I get into soldering and desoldering. I want to make this do something. Other than that, though, this is how you do it, and it's very easy to do. You can use any breadboard you want. I just used a small one here so I could fit it into the camera. Okay, that was how I did this. All right, but that's the lesson for the physical putting it together. If I showed everything right, it's a little hard to do with a camera and video and juggle things at the same time. As much as I'm trying here, But thank you very much, and I hope this actually helps you for anybody that's even new at this, like I even still am. I hope that my little idea here helped you. And this one here, I taught myself, just looked at the schematics on the internet, and I just played around with it until I figured it all out. And this is a little example of what I did. So I hope you enjoyed this video. I will follow up on the other one as soon as I can. Thanks again.